Hi, welcome to the video. Today in this video I am going to go over some characteristics of graphs of polynomial functions, and we're going to take a look at a polynomial function and look at some of the characteristics that we've covered in previous videos in previous units. So first of all, just some review. What is a polynomial? Well, a polynomial can be written in standard form, and this is the standard form of polynomial: a sub 0 x to the n plus a sub 1 x to the n minus 1, and so forth till we get to a constant a sub n. The a's are constants, and the n's are powers, and the x's are variable. A lot of times, not a lot of times, these a's here are called the coefficients. This is standard form of a single variable polynomial. Sometimes it's interesting to know, and it's important to know, what makes something a polynomial and what makes something not a polynomial. Well, you can identify what a polynomial is by making sure that it has no negative or rational exponents for your variable. So if you have like maybe x to the negative 5, that is not a polynomial. If you have maybe x to the 1/4, x to the 2/3, or even if you have like a root, like the square root of x, that's not going to be a polynomial. You want to make sure there's no variable in the denominator, like 1 over x minus 1. That's actually called a rational function, so that's not a polynomial. Make sure there are no variables in your exponent. That's an exponential function. Or the inverse of an exponential is a logarithmic, so it can't be logarithmic. And it might be a logistic function. So any of those cases are not polynomials. Another thing we don't want to make sure that's not there is a trig function. We don't want to have like sine of x, cosine of x. Those are trig functions, not polynomials. Lastly, something that's interesting about polynomials is that you can either write them in standard form or they can be written in terms of its factors, and that's called factored form. So the example that I have here, we're going to be using factored form. Alright, so we have this example here, we have a function y equals x times x plus 3 times x minus 2 times x plus 4. This is in factored form. So if we wanted to write it in standard form, we would multiply the x in using distributive property, FOIL this out, then multiply it again. When you do all that work, you're going to get x to the 4th plus 5x cubed minus 2x squared minus 24x. Okay, and this is in standard form. It's going to be important for us to know how to have both forms and to see both forms to make some connections. So let's look at this graph here and describe some of the characteristics. So here I have this graph. I graphed it in my calculator. I used factored form when I plugged it in. You could use either factored or standard. Your calculator will know what you're talking about. And let's take a look at some of the characteristics. Well, let's take a look first at end behavior. End behavior, if you remember, is how the graph acts at the end. What does the y value do as x goes to infinity or x goes to negative infinity? Well, notice here, as x goes to negative infinity, y goes to positive infinity. So if you recall, we had this in terms of limits. The limit as x approaches negative infinity, and that end behavior was positive infinity because the y value is getting infinitely larger. It's just going to keep going. Okay, well, what about as we go to positive infinity? Well, as x goes out to positive infinity, y also goes to positive infinity. So this is the end behavior, what's happening at the end of the graph. Let's take a look at the x-intercepts. Well, notice here we have x-intercepts, here, and these 2 points. We have 4 of them. That's interesting. We have it at x equals 2, x equals 0, x equals negative 3, and x equals negative 4. Well, that's pretty interesting. They might have something to do with the factors. Okay, so those are the x-intercepts. The extrema, these are the max and mins. Notice here that there is one relative max and 2 relative mins. We can see that right here. There's a relative min. Here's a relative min. Actually, that's an absolute min, right? The graph will not go below that, so that's an absolute min. And then this is a relative max. So this particular graph has 1, 2, 3 peaks. Down here, down here, down here. That's interesting. So we might want to see how that relates to our equation, okay, our polynomial. The domain for this polynomial, as x goes out to infinity, it doesn't look like anything is restricted. So this would be all real numbers. And remember, we write all real numbers in interval notation as negative infinity to infinity. The range, well, the range also does the same. Well, actually, the range is a little different. The range stops right there. Right? So it has a minimum. I don't really know what that is. We can figure it out. I'm going to estimate. I'm just going to say this is A, because I don't really know what it is. I'd have to find it on the calculator. So my range is actually going to be, it's going to start at wherever that number is. Okay, guys, try not to get confused here. This is just the y value. I don't know how to find it right now. We will have to probably put it in a calculator and ask for that value. There is a way to find it, okay? There is a way to find it. You need a little bit of calculus. We can actually do some estimating. But for now, just the idea of range is from here and up, okay? So we're going to start at A and go to infinity. So these are some of the major characteristics of this graph. And tomorrow in class, you're going to be looking at each of these characteristics. And it turns out that we can really get a good idea of what this graph looks like just by looking at the standard form. So hopefully this gives you a lead-in on what we'll be doing and how are we going to connect each of these and really see what is it about these polynomials in standard form or factored form that we can take a look at and say, oh yeah, I know what my x-intercepts are. I just see them here. Oh, I know what the end behavior is. It's got a trick to it. I know how many extrema it has. What's the trick to that? What's my domain of polynomials? You're going to get all of that as we continue talking about this in the next few days. Thanks for joining me. Bye-bye.